In 1944, the German war machine was grinding to a halt, and the reason had nothing to do with bullets, bombs, or manpower. Germany was running out of oil. Allied bombers had turned synthetic fuel plants into smoking craters, and the most advanced jet fighters ever built sat useless on runways with empty tanks. The Luftwaffe was dying of thirst, and that's when one engineer proposed something that sounded completely insane. He claimed he could build a fighter capable of reaching twice the speed of sound, and he would power it with the only resource Germany still had in abundance: coal. Not refined fuel, not chemicals, but chunks of brown coal pulled straight from the ground. This is the story of the Lippisch P13a, and it might be the strangest, most desperate, but brilliant aircraft design to come out of World War II. By 1944, Germany's oil situation had become catastrophic. Allied bombing raids specifically targeted synthetic fuel facilities, and they were devastatingly effective. Production dropped from over 300,000 tons per month to less than 50,000 tons by September 1944. The Luftwaffe received priority, but even frontline squadrons were grounded for days, waiting for fuel deliveries. That never came. The Me-262, the world's first operational jet fighter, could have changed the air war entirely. It was faster than anything the Allies had, and German pilots loved it. But here's the thing. It sat on airfields across Germany collecting dust because there was no kerosene to fill its tanks. Meanwhile, Allied bombers flew overhead in formations of hundreds, sometimes thousands, dropping destruction with almost no opposition. The German high command was desperate for any solution, no matter how unconventional. And unconventional was exactly what Alexander Lippisch specialized in. Dr. Alexander Lippisch was not your typical aircraft designer. While other engineers refined conventional designs with straight wings and traditional tails, Lippisch was obsessed with geometry. He believed the future of flight belonged to radical shapes, specifically the triangle. He had already proven his genius with the Me-163 Comet, a rocket-powered interceptor that could climb faster than anything in the sky. The Comet was terrifying to fly and killed almost as many German pilots as it did Allied aircrewmen, but it worked. Lippisch understood speed in ways that few others did, and he knew that conventional aircraft designs would never break the sound barrier efficiently. His solution was elegant in concept. Remove the horizontal tail entirely. Fuse the wing and fuselage into one unified delta shape. Create an aircraft that sliced through the air like an arrowhead rather than pushing against it. The P-13A was born from this vision, and it looked like nothing anyone had ever seen before. If you're new here and you want more stories about insane engineering projects that changed history, hit that subscribe button now. The Lippisch P-13A looked less like a 1940s aircraft and more like something from a 1980s science fiction film. The entire airframe was a pure delta shape, a perfect triangle when viewed from above. There was no horizontal stabilizer, no conventional tail, just a large vertical fin rising from the rear of the fuselage. The pilot didn't sit in a traditional cockpit at the front. Instead, the pilot position was integrated into the base of that vertical fin, giving an unusual but effective view of the surrounding airspace. The entire front section of the aircraft was essentially a massive air intake, feeding the revolutionary propulsion system mounted in the center of the fuselage. Lippisch calculated that this shape would remain stable at speeds exceeding Mach 2, something no conventional aircraft of the era could achieve. The delta wing generated lift differently than traditional wings, creating powerful vortices along the leading edges that actually improved handling at extreme speeds. But the airframe was only half the challenge. The real question was how to power this thing without a drop of petroleum. The propulsion system Lippisch designed was both brilliant and borderline insane. He proposed using a ramjet, which is essentially the simplest jet engine possible. Air enters the front at high speed, fuel is injected and ignited, and the expanding gases exit the rear to create thrust. No moving parts, no turbines, no compressors. But here's the thing. Ramjets normally burn liquid fuel. Lippisch wanted to burn solid coal. Take a moment, drop a comment with your thoughts on this insane piece of aviation history. The solution he developed involved a rotating wire mesh basket mounted inside the combustion chamber. Ground coal, specifically lignite, would be loaded into this basket before flight. The basket would spin at approximately 60 revolutions per minute during operation. As superheated air rushed through the engine, it would pass through the spinning basket, igniting the coal particles and carrying them into the combustion zone. The burning coal would reach extreme temperatures, and the expanding gases would provide thrust. Lippisch calculated that 800 kilograms of coal could power the aircraft for approximately 45 minutes of supersonic flight. On paper, it was genius. In practice, it was a nightmare waiting to happen. Loading the aircraft with fuel was dangerous enough to make ground crews nervous. Fine coal dust is extremely flammable, and a single spark during the loading process could trigger an explosion before the aircraft even left the ground. Every refueling operation was essentially handling explosives. The ramjet design meant the engine produced zero thrust at standstill. The P13A couldn't take off under its own power. It would need to be launched using rocket boosters or towed to altitude by another aircraft before the main engine could ignite. This added complexity to every single mission. And that's when the design got even more extreme. The original concept included no conventional weapons. Lippisch proposed using the aircraft itself as a weapon, reinforcing the wing leading edges with heavy steel and flying directly into Allied bomber formations. The P-13A would slice through wings and tail sections like a supersonic guillotine, destroying bombers through physical impact. The pilot was expected to survive these collisions somehow, and if the aircraft was too damaged to continue, they would need to bail out. At Mach 2, in 1945, no ejection seat existed that could handle those speeds. So, attempting to exit the cockpit at supersonic velocity would have been fatal. The wind blast alone would have been lethal before the pilot ever reached their parachute. What nobody expected was that this seemingly suicidal design would end up influencing aircraft for decades. Lippisch knew he needed to prove the delta wing concept could actually fly before anyone would take the coal engine seriously. Working with students from universities in Munich and Darmstadt, he began construction of a full-scale glider called the DM-1. The team built it in near secrecy using whatever materials they could find: wood, fabric, glue. It wasn't pretty, but it was functional. The goal was simple: prove that this radical triangular shape could take off, fly, and land without killing the pilot. By early 1945, the DM-1 was nearly complete. The war was clearly lost, but Lippisch and his team kept working. They believed in the design and they wanted to see it fly at least once. They never got the chance. In April 1945, General Patton's Third Army swept through the region, and American soldiers discovered the strange white glider hidden in a workshop. The troops had never seen anything like it. Photographs from that day show American infantrymen climbing on the wings, posing with rifles, completely unaware of what they had found. To them, it looked like something from another planet. American military intelligence recognized the DM-1's significance almost immediately. Under Operation Paperclip, the program that brought German scientists and engineers to the United States, the glider was flagged for priority extraction. But here's the thing, it wasn't finished yet. Rather than ship an incomplete prototype, American officers ordered the captured German engineers to complete construction under military supervision. The same team that had built it for the Luftwaffe now finished it for the U.S. Army. Once completed, the DM-1 was carefully disassembled, crated, and shipped across the Atlantic to the NACA Langley Research Center in Virginia. This was the premier aeronautics research facility in America, the same organization that would eventually become NASA. The Delta Wing glider that had been built with scraps in a German workshop was about to change American aviation forever. If you're enjoying this story, subscribing helps the channel keep making content like this. When NACA engineers placed the DM-1 in their massive wind tunnels, the results exceeded expectations. The Delta Wing configuration generated unique aerodynamic properties that made it exceptionally stable at transonic and supersonic speeds. The vortices created by the swept leading edges provided lift characteristics that conventional wings simply couldn't match. This was exactly what American engineers had been searching for. The U.S. was locked in an emerging Cold War with the Soviet Union, and supersonic interceptors were suddenly a top priority. The data from Lippisch's captured glider provided a roadmap. Convair, a major American aircraft manufacturer, received the wind tunnel data and began developing their own Delta Wing designs. The first result was the XF-92A, an experimental jet that validated the concept with an actual engine. The resemblance to the P-13A was unmistakable. Same triangular planform, same large vertical stabilizer, same basic proportions. The only difference was the power source. American engineers used conventional jet fuel instead of coal. The XF-92A led directly to the F-102 Delta Dagger, which became a frontline interceptor for the United States Air Force throughout the 1950s and 1960s. Over 1,000 were built, and they served as the primary defense against Soviet bomber attacks for years. The F-102 evolved into the F-106 Delta Dart, an even more refined interceptor that remained in service until the 1980s. Both aircraft carried the distinctive Delta Wing shape that Lippisch had pioneered in his desperate wartime design. The connection runs deeper than just the wing shape. Lippisch himself eventually came to America, along with many other German engineers, recruited through Operation Paperclip. He continued working on advanced aircraft concepts, consulting with American aerospace companies, and contributing his expertise to projects that would have been impossible in war-torn Germany. The coal-powered ramjet never flew, but the aerodynamic principles Lippisch developed became foundational to supersonic flight. The Concorde, the Space Shuttle, countless military jets around the world, all of them trace their Delta Wing heritage back to that strange triangular glider built in a German workshop during the final months of World War II. Historians still debate whether the coal-powered ramjet could have actually worked. The concept was theoretically sound, but the engineering challenges were enormous. Coal combustion produces massive amounts of ash and particulates that would have clogged the engine rapidly. The extreme heat might have damaged or destroyed the combustion chamber within minutes. Maintaining consistent thrust would have been nearly impossible with solid fuel. And that's assuming the aircraft survived its ramming attacks against Allied bombers. The physical stresses of supersonic collision would have tested the airframe beyond any reasonable safety margin. Pilots would have faced near certain death with every mission. But here's the thing. Germany in 1944 was not operating under reasonable conditions. The fuel shortage was so severe that any alternative seemed worth exploring. Lippisch was trying to build a weapon from desperation, using the only resource available. The P-13A represents something fascinating about human engineering. When pushed to absolute limits, people find solutions that seem impossible. The coal-powered supersonic interceptor was insane, but the Delta Wing it introduced was revolutionary. The Lippisch P13a never fired a shot, never engaged an enemy bomber, never even completed a single flight. On paper, it was a failure. The war ended before the prototype could be finished, and the coal ramjet remained an untested theory. But the ideas behind it changed everything. The delta wing configuration that Lippisch designed became the dominant shape for supersonic aircraft throughout the Cold War. American, Soviet, French, and British engineers all adopted variations of his triangular planform. The Concorde crossed the Atlantic at twice the speed of sound using a delta wing. The space shuttle glided home from orbit on delta wings. All of that traces back to an engineer in a bombed-out workshop in 1944, trying to build a fighter jet that ran on coal. He failed at his immediate goal, but he succeeded at something far more lasting. He proved that radical thinking could solve impossible problems, even if the solutions took decades to fully realize. And that might be the real lesson of the P13a. Sometimes the craziest ideas are the ones that matter most. If you made it this far, you're exactly the kind of viewer this channel is built for. Subscribe if you haven't already, and drop a comment with your thoughts on this insane piece of aviation history.